Okay, good morning. This is April 20th. This is Pre-Calculus Honors. We're switching over the topic now to something it's a bit of a review, but it's an important topic, so I wanted to go over it again. It's called inverse functions. Well, I believe we had the algebraic calculation of inverse functions, which we'll get back to, but today I want to go into a little bit of the more of the theory behind it. In particular, how to get the graph of an inverse function given a graph of a function. Okay, so basically, think of an example of population as a function of time. So you've got population growth. You have a function f of x. The input is the year. The output is the number of people or animals or whatever it is you want to measure. So for example, we could take the years from 1960, 61, 62 up to 2019. And if we plug these years into the function, we're going to get numbers. So for example, f of 1972 is 4.75 billion, meaning the population of the world was 4.75 billion in the year 1972. Same thing for 1980, we get 5.2. 1985, we get 5.52. So the graph of this function might look like, it might be a straight line, it might not be a straight line. Usually it's not, usually it's some sort of exponential growth, but we're going to make a simple assumption here. So you could flip around the question and say, well, previously the function was saying if you plug in a year, it's going to tell you what the population was in that year. Now you could flip the question around and say, given a year, what was the population? So in this case, you're going to say, you're going to plug the population number into another function called g, and you're going to get a time or a year. So for example, let's say g evaluated at 5 billion is going to be 1975, because in 1975 the population was 5 billion. And in this case we would get a graph, some sort of a graph. I didn't put the dots in here. Let's put in some dots, something like this, to represent that when the population was some number that occurred at some time, in some year. Now the question is, what's the relationship between these two functions? Well, think about it. If we take the composition of f and g, let's say the function f evaluated at g of 5. Well, what did g of 5 say? G said, well, it was giving you the year in which the population was 5 billion. So g of 5 is 1975. And then f told you what the population was in the year that you plug in this case 1975. So when we take the composition of f and g and evaluate it at 5, you get f of 1975, but f of 1975 is just 5. So f composed with g evaluated at 5 is 5. And if you do it the other way around, and take g composed with f evaluated at 1975, you're going to get g evaluated at 5, but g evaluated at 5 is 1975, because in 1975 the population was 5. So if you have a function in its inverse, then when you compose the two, f of g of 5 is 5. It doesn't do anything. G of f of 1975 is 1975. It doesn't do anything. Well, way of saying that is that f and g are inverses because they, when you compose them, you get the so-called identity function. The identity function is the function that doesn't do anything. So f of g of 5 just gives you 5. G of f of 1975 is 1975. So note that the point 1975 and 5 is on the graph of the function f, because f of 1975 is 5. And 1975, is also on the graph of the inverse function g of x, because g evaluated at 5 is 1975. In general, if the point AB is on the graph of the function f of x, then BA, just flipping the x and the y coordinate, is on the graph of the inverse function g of x. Now, the inverse function is usually written f inverse of x. So this is g of x. So BA is the reflection about the line y equals x. Let me go into that a little bit. Now, so to say that AB is on the function as on the graph of the function f is to say that if we look at the x value a and we look at the y value b, then this point lies on the graph of f. Now I've also drawn the line y equals x here. This is the line where the y and the x coordinates are the same. So if I take this value a and I vertically project it up until it hits the line, the coordinates of this point are going to be AA. Okay? If I look at the intersection with the y-axis and project this over to the line y equals x, I get BB, because this value is B. The y-coordinate is B, which means the x-coordinate has to be B also, because you're on the line y equals x. Well, that means if you project this down to B on the x-axis, you're going to get this point, but you also get up here, this intersects at the y-axis at A. So if you project this over here, your x-coordinate is going to be B and your y-coordinate is going to be A. Okay? So here is the geometric reflection around the line y equals x of AB, but just obtained by flipping the x and the y coordinates. And you can see the symmetry here, because if you look at this rectangle, you get AA, then BA, then BB, then AB. And if you look at this diagonal connecting these two points, this shows you the geometric symmetry around y equals x. So to get the graph of the inverse function, you reflect the graph of the function f about the line y equals x. And we're going to get more into that, but try to follow this argument. Now, the exercise I'd like you to do, and I'm going to get into the what we're going to try to do in the course for the rest of the year. But I'd like you to do these two problems. The problems, it's relatively simple, totally simple. Write a table that represents the inverse of the function given by the table. So here you have your x and your f of x. Now notice that the x values are written in an ascending order from 1 to 5, and in this case from -1 to 3. So what you should do is, this is going to become your domain. So you should write 1, 2, 3, 4, and 6, and then put in the corresponding column for the inverse function. And do the same thing with this. It's a very simple exercise. Now, if you want to take it a little bit further, you could graph these points by just plotting them, and then construct your new table and plot those points and compare the two and see if you can confirm the symmetry around the line y equals x. Now, for the rest of the year, I'm going to say it now, and I'll repeat it in the class. I want you to, the grade is going to be based on assessments based primarily on the work that you do. So I'm most concerned here with participation. And that means showing up. And when I give you an assignment, I'd like you to write it out, even if it's simple, write it out and photograph it and hand it back. So I'd like you to do that with this assignment. Have it done, hopefully by tomorrow. Send it back. I will put it in as an assessment. So, most of your grades are going to be based on assessments which show your participation. So participation from now until the end of the year is going to be really important. So I will be tracking who is showing up, and I will be following up. I will be sending out emails to make sure you're doing the work, which is not going to be as intensive as given these difficult times and difficult situations. I want to keep it a little bit on the light side, as you can see from this exercise, which is pretty simple. So if you have any questions, given that I'm going to be attempting to do the class live, please feel free to ask questions, and do ask questions. Okay, so thank you, and I will see you tomorrow.